Ever since generative AI entered the business conversation, it's become challenging to separate the idea of being future ready from adopting AI. We hear literally everybody now in the business world talking AI. However, whether it's generative AI or other types of AI, succeeding with AI initiatives comes with businesses facing a variety of unforeseen challenges. Today, we will explore how a cutting edge technology, evolutionary AI, can help enterprises choose the best recommendations from predictive models and transform their approach towards problem solving and decision making. So, welcome to this Times Techies webinar. I'm Sujit John, and I have with me my colleague Akhil George. The two of us will moderate the discussion, which we're having in association with Cognizant. And joining us today are three highly accomplished AI researchers and professionals based out of California. We have with us Babak Hodjat. Babak is CTO of AI at Cognizant. He leads the company's Advanced AI Labs, a team of developers and researchers bringing advanced AI solutions to businesses. Babak has started a number of Silicon Valley companies as main inventor and technologist. Prior to Cognizant, Babak co-founded and served as CEO of Sentient, responsible for the core technology behind the world's largest distributed AI system. Earlier, Babak also co-founded Dejima. He's the primary inventor of Dejima's patented agent-oriented technology applied to intelligent interfaces for mobile and enterprise computing. This is the technology behind Apple's Siri. Babak has published many papers in the fields of artificial life, agent-oriented software engineering, and distributed artificial intelligence, and has 38 issued US patents to his name. Welcome, Babak.
Thank you very much.
We have Risto Miikkulainen. Risto is VP of AI Research at Cognizant and a professor of computer science at the University of Texas at Austin. His current research focuses on methods and applications of AI in decision making, particularly those based on neuroevolution, as well as neural network models of natural language processing and vision. He has authored over 500 articles in these research areas. At Cognizant and previously as a CTO of Sentient Technologies, he's scaling up these approaches to real world problems. His work on neuroevolution has recently been recognized with the IEEE CIS Evolutionary Computation Pioneer Award, the Gabber Award of the International Neural Network Society, and Outstanding Paper of the Decade Award of the International Society for Artificial Life. Welcome, Risto.
Thank you. Pleasure to be here.
And we have Amir Banifatemi. Amir is technology and innovation strategist at AI Commons. AI Commons is a non-profit initiative that is seeking to bring the benefits of AI to everyone and use the technology towards social and economic improvement. Amir is a visionary technology executive, investor, and thought leader with over 25 years of experience creating companies and initiatives that generate ecosystems of technology-based ventures in new markets. Recently, as Chief Innovation Officer at XPRIZE, Amir orchestrated global competitions advancing AI and robotics while prioritizing ethics and safety, demonstrating responsible innovation at scale. As founder of the AI for Good movement, he established the annual AI for Good Global Summit in Geneva, aligning technological advancement with UN Sustainable Development Goals. Welcome, Amir.
Thank you very much for inviting me.
So why don't we just jump into the webinar? Maybe all three, if you can help us understand, what AI adoption trends are you seeing across industries? What are the common challenges businesses face when implementing or using AI? If you could share us a few examples to illustrate the challenges, that would be great. Who wants to go first?
Babak, you want to start?
Sure. Yeah, I mean, the challenges of AI are many. The most important, I think, is the challenge of expectation, unmet expectation usually. AI is compared with human intelligence or maybe all of humanity or sometimes with, superhuman intelligence. And so there's a challenge of expectation. There's also a challenge of infrastructure. Is the data ready? Are the processes in place already? Where do we adopt the AI? What we saw over the last year and a half was a lot of interest in generative AI in particular, and having experienced ChatGPT as this harbinger of generative AI, being very intelligent and understanding language, many of the use cases originally that companies and clients have been working on have been some form of chatbot interface into, for example, the proprietary data sets, or augmenting their support backends, as well as some form of developer productivity. So the expectation primarily has been around improved productivity. Can we have our developers be more efficient? And that's partly because generative AI has proven to be quite good at writing code, not very long code, but the parts of code are augmenting or improving or even adding test cases for code. So generally, that's what we're seeing. In my opinion, it's still very much scratching the surface of applicability of AI in companies.
Yeah, and I'd like to emphasize something that Babak said, that companies are not ready. I mean, the infrastructure is missing, and there are a couple of different aspects of that. So the first one is that even though the companies are collecting data, and AI is very data hungry. I mean, you need data to learn, you need data to make decisions. They might have data, but it's siloed. Different pieces of it are in different places, and they are not collecting the right kind of data. Like, for instance, if they make a decision, what are the outcomes of it? We need that kind of data to really have a large impact, and that's not usually often available, and it's hard to collect. Also, the infrastructure, where do you actually put the AI in the organization? And then people, how do you actually work with AI? AI won't take over from people, but it helps them. But people don't know how to actually take that help and do better with it. So all of those are major challenges.
Amir?
I concur with what Babak and Risto mentioned. I think the issue with data is a real one, because what has happened in the generative AI world is mostly a public version of using language models for creating text. But in reality, if you think about enterprise deployment and launching AI solutions, you need to have access to quality data and availability data on the long term. It's just a one-time access is a long-term access, reliable access. Data also means that companies have to look at the ethical implications, responsibility implications, and legal implications, and how they use their data and how they manifest data to their clients and how to integrate that. And actually, if it's within the enterprise or for their clients or for organizations, expertise matters. As Risto mentioned, expertise is not something that has been shifted easily. We need to make sure that not only there is enough technology oriented people, but also on the overall enterprise, there is understanding of what AI is, how it's implemented, how business processes can be shifted, how these solutions can be integrated with the existing infrastructure and legacy systems, how they're going to be interoperable, and if enterprises are connected to other organizations, how this interoperability also manifests itself. So there is a web of issues that is brought back right to the table, because now we are shifting to new models that generative AI is just a part of that. In addition to that, there is definitely a cost of integration and uncertainty of return on investment right now for many companies that are trying to figure this out. There is definitely major benefits, but those benefits are not fully scoped out always based on different industries. For instance, in the legal industry right now, the shift to generative AI is definitely jeopardizing the legal business. When you think about manufacturing or healthcare, those benefits are less impacting researchers, but more the time to market. So based on different type of industries, the return on investment can change. Also, finally, there is a lack of trust in AI systems today that we don't know to what extent they can be employed without risk, with full safety in place, and also with trustworthiness and reliability, because scaling is an issue. So what works in a pilot environment might not always work at scale. These are some highlight of issues that companies are facing right now.
The data part of it, can you explain? I mean, I thought countries like India would have a big, I mean, a lot of people still using pen and paper and stuff, but even in the US and advanced countries, there's a lot of digital transformation yet to happen. Is it to collect all this data and things? Risto, you were talking about data collection.
Yeah. This is part of it. Even though companies do collect data, and it's, transactions are often really recorded digitally already, but they're done with different systems, and they go to different databases, and they have different formats. And we have to bring all of those together. And I mentioned indeed the decision making. That means that when you are making decision about, say, how to allocate marketing dollars, well, you have to somehow figure out how well it worked. And that's the kind of data that's not really easy to get, because it has a time delay. There's a different measurements. Even the measurements are not really all that clear always. So that's still a challenge. Notice the one thing that we haven't pointed out is the technology itself. I mean, AI can already work quite well. That's not really the crux. The crux is to make an environment for it so it can shine. That's where the challenges are: people and organizations.
Okay.
So standardization, that seems to be one huge issue, right? But any new technology, isn't that normal? Or slowly you would find a standardization of formats will occur?
There are some very interesting properties with generative AI that actually help us with many of these challenges. Sujit, you mentioned, collecting data with pen and paper. Well, generative AI is actually increasingly good at unstructured data as input and structuring data. So they could help us with that. Generative AI could be thought of in many cases as a knowledge worker in a box that can actually operate with natural language. So Akhil, you mentioned standardization. If the standard of communication is natural language, you can express anything in natural language. And so the communication between these AI nodes that are representing different modules could be in natural language, and therefore simplify the way we kind of wire together and structure these workflows. So I think while absolutely there are many, many challenges, and I think we're really not quite ready. There's a lot of work to be done to prepare to adopt AI, but AI itself can actually help us with that.
The integrations that Amir was talking about, can you elaborate some example, Amir, of what kind of integrations are required?
Of course, one integration is with legacy data that is fully integrated in the business processes that you don't want to change because those are the practices. I mentioned the legal business, which is an example. It could be manufacturing, it could be logistics. You don't want to necessarily jeopardize the whole business process. So integration of that flow of business and decision making, integration of people and processes needs to be taken into account. You can adjust, but so adding the generative AI capability to that is an issue, because at one point you add that at the beginning, at the middle, you integrate it into the process. If you integrate it in the process, we can probably jeopardize some of the outcome of that well-oiled routine that the company rely on for practicality, for performance, but also for cost control. So it has some impact on that. So integration is an important part, which is system integration, but also is business process integration, but also training and making sure the outcomes are fully understood.
And for collecting data responsibly and all that, how do you prepare an organization for that?
Well, Risto mentioned the collection part, which is very important. If a business relies on quality data and they're buying that data from trustworthy sources and repeatable sources, that data continues to be acquired. Then it's how to actually integrate that data into solutions that benefit from the generative AI part. If data is not available and you rely on external sources of data, then there's a huge issue of hallucination and behavior from models that you may not be able to control. Also, models are not necessarily a closed box. They behave in a certain manner. We don't know how they always behave. So access to data has to be reliable in the sense that you can always predict the outcome of the model. Data is a big issue also because it leads to some IP litigation and access to that. You can see that in the entertainment business, you can see that in in election, you can see that in many areas where proper data structured would lead to some form of outcome, and how this data can be used for decision making. Whether the decision making is at the lowest common denominator, for instance, for elections or public health communications, or is at the enterprise level, or as a very complex system integration level.
Okay. Babak and Risto, I know Cognizant talks about this concept of evolutionary AI. You have, I mean, both of you personally have, of course, been very involved in this and done a lot of research around this. I mean, so this is an answer to the limitations of using only predictive models, from what I understand, the way you look at it. Can you explain that?
Yeah, that's really our bread and butter. We believe there's a great opportunity in that. The difference is that most machine learning, including the generative AI models, they are based on interpolation between things that you already seen and predicting decisions that you already seen before. Like, here's a picture, what's in it? Well, you've been told that there's a dog, and you now can recognize many different kinds of dogs. But that's really leaving money on the table if you leave it at that, because you can also use AI to come up with solutions, not just to predict what will happen, but actually give you suggestions what you should do about it. And that's what evolutionary AI in particular is really good at. We have a population, like in biology, a population, and it's evolving towards better behavior. We reward the population if it comes up with decisions that lead to better outcomes. And then we use mechanisms adapted from biology, like crossover and mutation, to come up with new solutions. And this way, over time, we can discover solutions that are actually pretty hard to discover, even those that human designers would have a hard time coming up with, because we have a population we can explore, we can try different things out, and that way discover new things. And I think that's really powerful in the future, especially when we now have so much compute that we can use it to explore. And models that are predictive, so that we can actually evaluate these candidates against the predictor and not necessarily in the real world. And in this way, it can be applied to many different tasks where you have to be creative. Indeed, I mentioned allocation of money to marketing. It could be better treatment in healthcare. It could be designs of gas turbines. Many different domains where new solutions are needed, and evolutionary AI can help come up with those.
Yeah, so the properties that Risto just mentioned are really well suited for decision making, because when you think about it, we want our AI to be aligned with the way we value decision making, basically. So if we have some KPI, we have some outcomes that we care about, we want the AI to actually be solving for those outcomes. And so those outcomes, and it's always plural, it's always more than one. If you're going for more sales, you also want to control your costs and, you know, improve your revenue. And these outcomes are often not aligned. You know, you look at the pandemic, you want to reduce the number of cases, but at the same time, you don't want to have a major economic impact on people's livelihoods. And these kind of are not always aligned with each other. And evolutionary computation, evolutionary AI is very good at coming up with strategies that are balancing, give us a balance of multiple outcomes, and let us then choose which balance of the outcome is more interesting to us. And so the way we set these systems up is by first identifying those outcomes, then coming up by using AI and generative AI and so forth, coming up with what we call predictors. So in the presence of some decision, what would the outcome be? So for example, if we shut down schools, how is that going to affect the economy? How is that going to affect the number of cases? If we shut down work, if we vaccinate, and so forth, right? So for different strategies that we take, what is the outcome going to be? Those are the predictors. But predictors alone are not enough. If you know what's going to happen in the future, you still don't know what to do and in what order and how much of which in order to find that balance of outcomes. And that's where evolution comes in. So evolution basically searches the space of all possible decision strategies. That's a very, very large space usually. And it searches it very efficiently. So we can quickly come up with those strategies based on what the predictors are predicting for us. And how do we put this to work? Well, at the point where a decision maker wants to make a decision, it can say, here's the state of the world right now. For example, here's the state of the pandemic, or here's the state of my business. And the prescriptor, quote unquote, which was what we just evolved using evolutionary computation, is going to tell us, here's what you need to do in this state, and here's what's going to happen if you do it. So it gives that sense of collaboration as well. Not only am I telling you what I think you should do in order to hit the balance of outcomes that you care about, but I'm also predicting what's going to happen if you do so. So therefore, you can come in and modify it and say, well, closing schools right now is an option because it's summertime and schools are off anyway. So let me actually do that and see what happens. So you can actually pull the various different levers, make some changes, send that to the predictor, and the predictor will then say, well, here's what the outcome is going to be if you do that. It's kind of conducive to the way we make decisions. We kind of run various different scenarios hypothetically, and we come up with the best way to make a choice. So evolutionary AI, the way Risto and I just described, really works well in an environment where you can identify the outcomes and collect the data on an ongoing basis and make these optimizations.
And you've seen better decisions happening faster and all of that in actual real world cases.
Absolutely. We see that all the time. And when you think about it, our organizations are set up to make decisions. So it lends itself very well to AI enabling businesses where you're constantly making decisions based on the data that you have and tackling more than one outcome at the same time. And to your point, Sujit, we can actually measure how well we've impacted the decisions against the baseline of what decisions were already being made or are being made in analogous situations. So yes, definitely there's a measure there that we can rely on.
Yeah, but there's also an aspect to it, like I mentioned, creativity, that in this manner we can come up with solutions that are really hard for people to come up with. So for instance, in designing growth recipes in agriculture, we had this experiment where these recipes were designed by AI, how much water, what kind of temperature, what kind of nutrients, what kind of light were given in a computer-controlled greenhouse. And it turned out that our plant, basil, which we tried to grow fast and big and tasty, did not want to sleep. It wanted to have lights on 24 hours. And this was a big surprise to the biologists because we started with having 8 hours of darkness or 6 hours of darkness, because that's what happens in the world. But it turned out that was just a false assumption. Basil thrived when lights were on 24 hours. And this is the kind of solution that would be difficult for humans to discover because they have all kinds of assumptions, and AI, evolutionary AI, does not. And it can discover solutions like that, which otherwise, and that actually are useful. It would be another aspect of it is also we can use AI to bring together human creativity too. So in the example that Babak mentioned, which was making recommendations for non-pharmaceutical interventions in the COVID-19 pandemic, in the X Prize, we worked with Amir in coming up with competition so that people can submit their own solutions to how the pandemic should be managed. We used AI to bring all of those together. First, the human solutions were transformed to similar population, and then evolution were recombining those solutions and came up with better solutions than humans could or evolution alone. So there's aspect of evolution that can also bring the community together and be more creative that way.
Coming back to that basil example, could you let us know how exactly did the AI system create new solutions?
Sure.
Come up with new solutions? What did it?
Yeah, so you have to start with something to create the predictive model like Babak suggested. So we planted about 300 recipes, plants according to different ways of controlling the light and water and nutrients and temperature and so on. Those were the ones that the biologists came up with, the usual suspects, as well as some exploratory examples, very different kinds. And we have now 300 points about how the plant grows under different conditions. And then we built the predictive model, trained, I think it was a symbolic regression model at that point. And now when we have a predictive model, we can explore widely. We can come up with crazy recipes and ask the predictive model, well, what would happen in this case? What would happen in that case? And this way, find those solutions that are hard to find. And it happened actually that we had set up a limitation of 6 hours of darkness, and all the solutions that evolution was exploring were right at that boundary. So at that point, we said, well, open it up, try other solutions. And these solutions are nothing but just simple vectors of numbers. How much light, what kind of light wavelength, how much water, and so on. So those are numbers that evolution modifies using these operators of mutation and crossover, taking two solutions, parts of two solutions, putting them together, as in biology, in crossover. And this way you are exploring the space intelligently, taking into account what you've seen already, how well they worked, and trying more solutions like that. And in that sense, then, when we open it up, evolution pushed the solutions all the way to the end, and we had 24 hours of sunlight in these solutions.
Fascinating. Amir, you also worked with these technologies?
I was involved with, as Risto mentioned, in that project that we jointly worked together. And my view of evolutionary AI has have a complementary view of that. I think what was mentioned in terms of creativity is true, but I think two observations. One is that evolutionary AI have some advantage over traditional decision-making technologies. They can, because those algorithms can create entirely new solutions and not derive from existing knowledge. So if you don't borrow from existing knowledge, you're allowing to discover strategies that human may not have thought about. So that's the creative process and this opportunity. At the same time, they can optimize multiple objectives, right? Because if you have a goal and a solution space and you want to look at multiple objectives, you can actually optimize for that on multiple objectives. The fact that there is creative process and intuitive, the models that are coming out of that are probably more transparent and more explainable in general because of that reason. So basically, it's a complementary approach to traditional black box deep learning models that are using only data to behave, but you don't have any explanation. So there's this attribute of evolutionary AI to me. It's somewhere between deterministic Bayesian models and quantum mechanics models, right? We can actually go and find multiple objectives and multiple space. You can basically discover solution spaces, but at the same time, they can be explainable and transparent. So these are the two attributes that I've observed makes a difference.
Oh, fascinating. I just want to work. Okay, go on, Akhil.
No, if someone could help us understand, could you help us locate evolutionary AI in the field of AI and ML? Where does it come up? Is it close to generative AI? We have no idea.
Sure.
If you could help.
Yeah, that's something
Sure,
what I was want to ask you. This is work that all of you started several years ago. I think before we started hearing the words generative AI and all that. Did generative AI impact this work itself?
Yeah, sure. Evolutionary AI has been around for a long time, from the 70s. And it's part of biologically motivated machine learning. There are other areas like that, including neural networks, which is what generative models are based on, as well as swarm optimization and colony optimization, other methods like that. So you look at biology and you notice it's doing pretty well in certain problems. And then you try to abstract that and build computational model to emulate that. That's the motivation for it. But in a big scheme of machine learning, most of machine learning is about supervised learning. So you collect big data sets where there are examples and then there are targets. What you want to do with that example. For instance, a picture of a dog and then a labeled dog, or text that's categorized somehow. Or even the generative AI models are trained by just predicting the next word. The next word is always there. you are backpropagating your gradient using gradient descent from the next word. So you have supervised learning techniques. That's one big category and very successful category. But then there's a category where you get very weak feedback. You only know how good your solution is, not what it should be. So you are actually making a suggestion, maybe from an image that this is some kind of an animal, and you get a little bit of reinforcement. You're not told that it's a dog. You have to explore and you have to search. And there are a couple of methods that do this kind of search. Reinforcement learning is one, and evolutionary optimization is another one. And then others that are related to that are like particles forming and ant colony optimization, different ways of formalizing the search. And you are searching because you don't know what the optimal correct solution is. You have to find it through search. There's also a third category of machine learning, which is unsupervised learning, where you are just looking at the data and trying to find clusters and correlations. And it's more or less visualization of what the data looks like. But evolutionary optimization is in this middle range, where you know how good your solution is, but you don't know what you're actually looking for. You know when you get there because you are getting an evaluation of how good your solution is.
Okay. Great. I just wanted to ask you on the Cognizant itself. I mean, you have an advanced lab, AI lab, to advance evolutionary AI and developing applications around this. Can you tell us something about that, the lab itself?
Yes, we are in a unique position where Cognizant has been actually investing heavily in AI and generative AI. And we now actually have an AI lab, an advanced AI R&D lab based here in San Francisco, where we are actually doing core AI research. Which means that we're actually publishing papers in peer-reviewed journals and conferences. We have many patents that we've filed, so a lot of inventions, and really pushing the envelope on the core technology itself. And the way the lab is set up is we have both the R and the D, the research and the development. The cohering principle around what we research is AI-based decision-making. And therefore, evolutionary AI is a very important aspect of that. It's at the core of what we do. And so we've developed a platform to manifest the inventions that come through research. So many of the inventions, once they've been trialed, published, for example, we know what the benchmark is on them and so forth, then we actually pull them into the platform, which is called Neuro AI. And it's an amazing platform, actually. Enriched with generative AI, it actually allows us to build AI-based decision-making use cases within minutes, believe it or not. So from concept, it even helps us with the conceptualization itself. It actually helps us explore and find use cases within a business, all the way to actually seeing a user interface that's data-driven, that helps with the decision-making, as well as kind of giving us the art of the possible as far as the impact that we can make on the outcomes and the KPI that the business cares about. The whole thing in minutes, part of the reason for that is because we generate synthetic data. And so, obviously that's the part that makes it, allows us to build these use cases within minutes, because as was mentioned earlier, data is a major challenge. But because we can actually create a decision-making workflow very quickly, we can see the art of the possible, and we can also see what are the requirements from a data perspective. And so then, as Cognizant, we can come in and help businesses provision that data. If there's third-party or public data that needs to be coming in, we can bring that in, clean the data up. Much of that could also happen using generative AI. And so there's a process to actually make that end-to-end prototype, if you like, make it real. But yeah, that's kind of gives you a sense of where we are with the lab, and we're actively hiring AI researchers and PhDs into the team to continue pushing the envelope on the science and technology.
Will any part of this be done out of India as well?
Absolutely. We actually, Cognizant has a very, very strong presence, as you know, in India. We have colleagues in India that are well versed in using evolutionary AI and neuro AI, and we do get their help. Currently, though, the main core of the R&D team is based here in San Francisco. However, we do have plans to expand. We also have sort of complementary to the AI labs, we have AI studios where we showcase a lot of the research and we co-innovate with clients. So these are setups where we can walk the clients through the innovations and how various different use cases can be created. And then there are stations where we can co-innovate with our clients. We actually have one in Bangalore, and we're opening more. We have one in New York, one in London, and so we're opening a number of studios, and these are complementary to the AI lab that I just mentioned.
Okay.
Could you help me understand a little bit about this leaf? Exactly. Are you saying with Leaf you can automate a lot of business strategy? Is that possible?
LEAF stands for Learning Evolutionary AI Framework, and it is the technology at the heart of making decisions. So we've literally been talking about it without mentioning the word LEAF, but that process, so that process of actually taking data and creating predictors that predict outcomes in the presence of actions that we're taking, that's step one. So we make predictors, and then optimizing a prescriptor using evolutionary computation against that is LEAF. Now, it has other aspects as well. For example, we measure uncertainty on the predictors. That's very, very important. Point uncertainty is important. Amir talked about trustworthiness. So, for example, if we're making if our predictor is making a prediction, but it's making it in a very, very unfamiliar setting for which it hasn't seen data before, it needs to tell us that it's not very certain in that particular prediction. So uncertainty kind of helps us with that. And other properties. So LEAF kind of covers that process of creating these decisioning use cases. Generally. So I don't know if Risto or Amir, you want to add more.
Yeah, it's the name that we gave to the technology that's underlying the platform that is Neuro AI. And Neuro AI also includes the generative AI LLM components that make it easier to apply to the world. So there are layers in this system. So LEAF is the core technology that then itself has multiple components: predictive technology, prescriptive technology, and uncertainty being some of those. So it is good to be able to refer to the technology separately from the platform that's an implementation of it. And that's why we have it.
Okay. That makes sense. Maybe we can touch on some real world examples now on how evolutionary AI helps speed up decision making across industries. Maybe we can start with healthcare.
Beyond the one that Risto, of course, gave a very interesting example. But Amir, tell me, in the area of AI for good and all that, the work that you do, is there some things that you can talk about?
Of course, thank you very much. AI for good usually is referred to focusing on sustainable development goals and societal problems. So as you know, the sustainable development goals, the 17 goals are dealing with no poverty, healthcare for everyone, education, life on earth, etc. So those 17 goals, and the impact of AI is going to be impactful for all of these. When it comes to evolutionary AI and traditional machine learning models, there are areas where when we have complex decision making, we have more constraint to deal with. For instance, rare diseases, right, as an example. How can you work on rare diseases from a pharmaceutical perspective? There is a number of drug candidates that need to be identified. The cost of drug research is huge, and the market is not that large. But you have to somehow deal with diseases that are prevalent in the world. And so how you can do that? So traditional models are not adapted, but when you think about if you want to find a cluster of potential molecules, right, for a given drug, and test, add additional constraints, for instance, for toxicity, for instance, or for including genetic background. Evolutionary AI or this approach will help actually accelerate the drug discovery part and add constraint. At the same time, if you want to distribute the workload of research in the different countries, you can think of evolutionary AI as a candidate for helping design experiments that are going to be localized to identify different type of research based on collective data that you have or the local cultural background issues. So having a way to integrate multiple constraints and be able to identify a variety of candidates or solution spaces is what evolutionary will shine and be complemented with other techniques. It's not just it's going to solve everything else. But instead, we'll talk about medicine personalization. Before we go to personalization, we need to identify the space for personalization. What is it? In some cases, it's going to be contraindication with different drugs. In some of the cases, it's going to be genetic background. In some of the cases, it will be cultural issues. Where you can actually lose weight or not lose weight. So personalization doesn't mean the same thing. There's a cultural or community issues. So it's not about one solution or the other, is how you can actually frame the problem space in a way that you can discover more. And from that perspective, on the AI good perspective, evolutionary AI and technology related to that could be a good co-pilot. We talk about co-pilot today, that is more on the generative AI part, but the real co-pilot would help human engage into the decision-making process and navigate through this maze of decision-making process. You're going to be more enabled by evolutionary AI technologies.
You've seen it being used by drug development companies and all that. Are they beginning to do that already, Amir?
I've seen a number of companies that they may not use the term evolutionary, right, but use the term neuro-inspired capabilities. Yes, we see companies and IBM, for instance, involved with some pharmaceutical labs to actually do faster drug discovery based on limited amount of data and identify, for instance, molecules, candidate, instead of going through the whole animal testing, they're shortcut the animal testing by doing in silico toxicity evaluation. So that shortcut the whole time to market by eliminating that. So instead of having, let's say, 2 million candidates, you go quickly to 150 candidates that are toxicity tested in silico.
What is your estimate? How much will drug development time come down by with all this?
I'm not an expert in genetic engineering or drug testing. I've observed it, but experts are saying that it could probably eliminate 1/3 of that time. There is still other times such as regulation issues, testing, real human testing, initial research, regulatory pressure, and go time to market. But the core research time, I think, would be shortened by 1/3.
Yeah, wow. Risto, Babak, any examples? Insurance, manufacturing, life sciences, healthcare?
Sure. One project that we're working on currently with University of Texas and Boston University on constant therapy is on optimizing rehabilitation of patients who had a stroke and they lost some abilities, language abilities mostly. And there's an app that gives exercises to these patients, and they can practice their language skills, naming, maybe sentences, maybe some reasoning, and get better. And the idea here is that there's a lot of data on what these patients are doing and how they have improved. So we can learn, again, a predictive model, and then we can learn to prescribe what exercises should they do at this point. All very hyper-personalized medicine in that sense, or treatment or rehabilitation. And we are hoping that indeed by customizing these treatments, the patients will get better faster and they will recover more fully.
Yeah, and while our lab and Cognizant is very much focused on AI for good type of use cases and research, as was mentioned just now, we also help with many business use cases. In insurance, underwriting is a good one. Let's say that you want to decide on an insurance policy and what the premium should be on that insurance, for example. But at the same time, you want to, so the outcomes that you want to solve for is to make sure that you win the the deal on that insurance, but also minimize risk on that deal. And that those are all measurements that insurance companies are quite familiar with. And of course, maybe there are other measurements as well, such as time to closing the deal and the cost to the insurance company as well. So again, we view these use cases by looking at the outcomes first. Other use cases are in procurement, in supply chain management. Price optimization is a good one. You have price elasticity, let's say in a retailer, and you want to set up the price for the various different products in a manner that improves your revenue while reducing your margins. Again, two outcomes that are kind of opposing each other, and you might have different goals for that balance of revenue and margin depending on where you are. If you've opened a store in a new location and you really want to, build that market out, the margin might be less important to you right now, and so you want to actually sell more versus the other way around. So in healthcare, we mentioned a bunch of different use cases, and the list goes on and on. In fact, there's so many use cases that rather than, while we've built many template use cases already in Neuro AI that we kind of reuse, but rather than reusing the templates, we actually use generative AI to identify the use case, and then we use generative AI to scope the use case for that particular client and interactively. So we use generative AI interactively. It kind of comes up with the list of data attributes that are the contextual data, what kind of decisions are going to be useful, and what outcomes might be interesting. And then interactively, we might say, well, we also have this other data, or we don't have this particular data type, or we are not allowed to use this data. And so we can interactively change the scope. And then that scope is used to generate synthetic data, as I mentioned, and then kind of orchestrate a decisioning system that uses evolutionary AI. So today, when I get in front of a client, rather than showing them pre-existing use cases that might not quite be what they're looking for, I actually build a use case for them right there in front of them. And it takes about 15 to 20 minutes to do that. I took a leap of faith about 2-3 months ago, and I actually did that on stage. And I went on stage not knowing what use case I'm going to build. It was scary, but I was actually able to build a use case. Our CEO turned to a client that was in the audience, and I basically interacted with the client and created a whole use case. I think it was in inventory management on the fly right there and then. And you can imagine this is partly because of the power of generative AI and orchestrating generative AI into the process of building these systems. But the end system that you create, I think I want to emphasize something that Amir also mentioned. The end system is not helping you with decisions based on the generative aspect of what it's trained on. You're open to a lot of risk if that's what you do, because it doesn't quite know much about your business, your workflow. It might hallucinate. It's really the end process is to actually have this be data driven based on the data that's running through your business specifically, and that's where evolutionary AI complements generative AI.
What about fine tuning and RAG, and aren't those supposed to counter those problems?
Yes. So fine tuning is when we take a generative AI system and we kind of bias it to answer in a certain way and not answer in other ways. That doesn't really bring in data. It doesn't actually add much to the foundational model. It just pushes it to behave in a certain way versus another. So while fine tuning is useful to get the generative AI to behave more predictably or behave better within a certain setting, it's not sufficient to actually be able to key off of real data that's kind of running through your business. RAG, or retrieval augmented generation, is a technique that is used to have generative AI be able to do what ChatGPT, for example, does, but against your unstructured document repository. That does, yes, indeed, that actually reduces hallucination because it's kind of directing the generative AI model to get its data for answering any queries from your unstructured data set, absolutely. And it's a component of a decisioning system. It could be. But that's the way we use generative AI as well, not restricting it just to unstructured data, but we use generative AI by telling it what tools it has at its disposal. For example, it has this predictor, it has this prescriptor. Here's where the data is. It can actually take natural language and make some queries. And so by restricting the generative AI to a certain set of tasks and API and data, we do significantly reduces its risks of just making stuff up.
Businesses have already started implementing these solutions, Babak. I mean, and if so, to what extent? What kind of results have they seen? Are there anything metrics that you can share in terms of benefits?
It's still early days. Yes, there are metrics, and there, I think there's in excess of 500 different projects that are underway. These are mainly sort of let's use this on one use case and see how it works kind of stage. It's kind of early and limited deployments yet, so we're still measuring those outcomes. But the early results look very promising. And again, it's that question of alignment. If your AI system is aligned with the KPI that you're tackling, you kind of get a sense of how it can impact that KPI already right up front when you actually set it up with the data. So yes, stay tuned. We'll have more use cases and actual numbers to quote soon.
Okay.
Amir, do you have any thoughts on this?
I'm not really deploying evolutionary AI like Babak and Risto are, but I thought about, because you mentioned examples, I think Babak mentions the insurance example, which is a real one. I think there's going to be meaningful results there. And it ties to the AI for good aspect of it, is that we all want personalized products, and insurance and is an example where cost of insurance is high and there is very little options for insurance companies to manage between risk assessment, underwriting, fraud detection, and to provide fair pricing for people that need that fair pricing. So in that maze of finding new products, I think evolutionary capabilities, with the help of generative AI, to start structuring right hypotheses and options, will be probably an example where we can see the birth of personalized products that could meet the requirements of cost control, affordability, but at the same time also manage risk and fraud for insurance companies, because these are two objectives that aren't always easy to manage at the same time. So the space to solve for that, I think, goes towards personalization of product that could help more people have access to insurance. That also can be health insurance, could be personal liability insurance, business insurances. Because today we're tackling them by clusters of behavior, but not additional constraints of affordability or other attributes.
Coming to the skill sets, how do young people get into evolutionary AI? How do they write evolutionary algorithms? Do they have to, like nature, do they have to learn how to mutate these algorithms?
Well, it's all part of general education in machine learning and AI, and it should be. Actually, it's not that hard to put together an experiment in this way. There are software tools available. Even if you write the original code, it's not that huge amount of code. The power is in iterating it many times, having the data and having the compute to do it. So yeah, you can start by looking at the literature. There are a couple of examples already out there, even a textbook and several textbooks, and then the software algorithms, software implementations, and examples that you can run. So even if it's not part of the formal education, you can certainly get into it. And that, I think, is really exciting about the AI today, and that it is actually accessible, that you don't have to have years of training. You can actually start with much smaller scale, understand what's going on, and apply it immediately. So that's why it's more closer to the crowdsourcing that we hope that everybody can actually use AI. You do have to have some technical training, obviously, to run software, but it is much more accessible than some of the more say statistics-based algorithms that require a more deeper understanding of the math.
Can we put a plug in for your book, Risto? So Risto is a pioneer.
Textbook on neuroevolution that will cover 30 years of this domain. Of course, the new aspects of integrating with the LLMs as well. So there, and that also comes with a lot of software exercises. Yes, that's the right way to get started. So read the textbook, do the exercises, apply the software, and you can change the world.
Wonderful. And within Cognizant, you're getting employees to kind of get trained in all of this. You think everybody should get trained, or some should get trained?
Absolutely. A lot of investment is going into upskilling our employees on generative AI and AI in general. We have a very strong sort of training department. We call it the Academy, Cognizant Academy, where we have courses for associates that can upskill and learn how to use these technologies. We're actually in the process of identifying skills that everyone in the company should have. There was actually a mandated generative AI course. I took it myself as well just recently. That was for all executives and VPs and so forth that we took. So a lot of emphasis there. We're actually in the process of launching a workshop for executives, mainly for our clients, together with code.org and a major university. I can't really name the name just yet, but hopefully in the next couple of weeks we can name it, a major Ivy League large university here in the US that also provides a certification. Education is key in this new world of AI. We talked about it earlier as well. Just keeping up with what technologies are out there is part of that adoption, challenge that companies have, and we have it as well. And we're a very large company. Very talented individuals work for Cognizant, and they're hungry to learn more. And it's a challenge for us to actually feed them, basically, with the latest and greatest technologies and tools to be able to use.
Wonderful. Amir, I know you have a hard stop, and a quick one. Amir, India has a very young workforce. What is your message to them? What should they be learning? How should they look at the future?
Well, beyond evolutionary AI, which is an important topic today, I think the skills that was mentioned by Risto and Babak are important, but at the same time, there are two skills that I think are important for younger generation. One is definitely math and mathematics and language, but problem solving and critical thinking. I think these technologies are evolving and we're really learning to use them more and more. But this system mindset and engineering mindset and thinking critically about problem solving and tinkering and experimenting is going to be very important, because many of these tools will become off-the-shelf products and capabilities that will augment our abilities. So thinking about social problems, issues, having knowledge representation capabilities and problem solving aptitude, I think is going to be the most important trait that the new generation will benefit from.
Also, I guess knowing the risks and pitfalls is also important, knowing where to use it and how to use it, for sure.
Yeah, my message is simply that what an exciting time this is to be alive. I mean, there's so much change that's going to happen. Cognizant did a study with Oxford University of the impact of AI, and I think they estimate it to be $1 trillion in 10 years 90% of their workforce is affected in using AI. Very few people actually left behind, but dive into it. You know, it's going to change the world, and it's really exciting to be part of it.
Wonderful. I think that's a great note to end on. A very exciting time to be in, but ensure you have your problem-solving skills, critical thinking skills, but also understand all the risks that go with it. Thank you, Amir, Risto, Babak. Really nice having you on the platform. Great discussion, and hope to see you all again some other time. Thank you.
It was
Thank
a
you very
pleasure.
much.
Thank you.
Thank you.
Thank you.
Bye.